This video is to show you how to do energy conservation with a spring. Word problem number 2. So now Leah held a 20 kilogram weight on the spring in the unstretched position, then released it. They give us the spring constant, so they give us K. They want to know how fast was the weight moving, so I need the velocity after it fallen 0.9 meters. Here's the key to this. I'm holding the weight in an unstretched position. That means that my potential spring energy is 0 because it's not stretched. My KE equals 0 that I put in to start with, so these are in because it's not moving. And the simple way to work it is that my potential energy is 0 to start with, because I can say it's 0 to start with anytime I want. And I know, so that means remember my energy in, so here's my energy in, so that equals 0, because they're all 0. So that means my spring energy out plus my kinetic energy out plus my potential energy out has to be 0. Because my energy in is 0, that means my energy out is always 0. So let's see, my spring energy is 1/2 kx squared. My kinetic energy is 1/2 mv squared, and so this is what I'm looking for, right? Plus my potential energy is mg. We usually say h, but I'm going to use delta x, so it matches this. So that equals 0. So I just plug my numbers in. I have 1/2. My k is 35. Oh yeah, my x is 0.9 meters. Sorry, got a little confused there. So times 0.9. Now, here's the deal. It's fallen. That has gone down. It won't matter on this part, but this should be negative 0.9 squared. But since it's squared, that one won't matter. But it's going to matter over here. The number one mistake people make on this problem is they don't use a negative for the x because it's gone down. Okay? So plus 1/2. The mass is 20. My v squared. Plus my mass is 20 times 10 times negative 0.9. So that equals 0. So now it's algebra 1. And I'm not going to take the time to solve that. So I can add these together and move them over here and then divide. Now, and when you do that, you get, and this is all on the worksheet, my V is 4.1 meters per second. It's actually going down, unless you want to argue that it went all the way down and back up. So it could have gone down to this height, or it could have gone down and back up. And you'd still get the same answer, except going down, this would technically be negative. But I'm just looking for how fast it's going, so I don't worry about the negative. Okay? The other way to look at this is my delta G, my change in potential energy of gravity has to equal my KE plus my energy of the spring. If you work it that way, then you can just use a positive x and not worry about it. But if you just solve it this way, you have to make sure you put a negative there.